We are going to do some age problems today, and we're going to attempt to do them with using only one variable instead of using two different variables. So the first one we're going to take a look at is this one. I've actually got three people in it. We start with Sam is twice as old as Marcel. Marcel is 3 years older than Jacob, and 4 years ago Marcel was twice Jacob's age. How old is Marcel? Doing these problems, I find that the most important thing is to identify kind of the comparative ages and who's the oldest and who's the youngest. So let's do that first, and I'd like to identify the youngest person first. In this case, Sam is twice as old as Marcel. So we know that between those two, Marcel is a little younger. Then when it goes on, it says Marcel is 3 years older than Jacob. So between those two, Jacob's younger. So overall, Jacob is the youngest, then Marcel, and then Sam. Now, the best thing to do here is to go ahead and make a table, and let's do that right here. And I like to have one more row than there are number of people. So overall, I'm going to need 4 rows, and enough to make sure that we have headers. Okay, so let's just stay there. And then I need one column for each time period. And so since I'm talking about present day or the current time, and I'm talking about 4 years ago, I need 2 columns on this side. Over here on the right, I'm going to just list their names. Sam, and we have, kind of going in order, Sam is the oldest, and then we have Marcel, who is the second oldest, and then the youngest, which is Jacob. Alrighty, I'm putting these numbers in here just so I can keep track of reasonableness when I'm seeing my answers and who's the oldest, who's the youngest. Okay, and then these 2 columns I'm going to use for now. When I put my information in there, I kind of know what's going on. And then since they're talking here about 4 years ago, I'm going to go ahead and use that as my other column. 4 years ago. Alrighty. It's very helpful to identify or assign the variable to the youngest person, and I'm going to go ahead and do that with Jacob. I think that seems to work best. So if I use J standing for Jacob, that really means what I'm doing is I'm going to say let J equal Jacob's, actually I should use an uppercase letter for Jacob's name, proper. Alright, capital J for Jacob. Jacob's age now, and that's very important that I identify when that is. Okay, and so reading the problem, we see that Marcel is 3 years older than Jacob. Okay, which means J plus 3. And then we see the first sentence said Sam was twice as old as Marcel. So that's going to look like this: twice or 2 times Marcel's age, J plus 3. Okay, and now we can talk about 4 years ago. Well, 4 years ago, Jacob was 4 years younger, so we'd write minus 4. And Marcel was also 4 years younger, so I'm going to take his current age, which is J plus 3, and subtract 4 for that expression. And then Sam was also 4 years younger, so I'm really just adding on minus 4 to all 3 of these. 2 times J plus 3, and then a minus 4. Alright? The one piece of information that they did give me, though, was that Marcel was also twice Jacob's age. Alright, so this right here, which is the expression for his age 4 years ago, is equal to twice Jacob's age. Now, it's real important that when we do these problems that you really think about, when you set up the equation, which one is going to have a 2 in front of it. Because often when you read it, it's tempting to go ahead and put the 2, kind of with the first thing you read. But in this case, just remember that Marcel was the older one. Jacob was younger. So therefore, I'm actually going to have to double Jacob's age for it to make sense. So let me go ahead and write that. The relationship between these two is that Marcel's 2 times as big, okay? So I need to write this way. Marcel's age at that time minus is equal to twice Jacob's age. Alright, so I'm going to get J minus 1 equals, by combining my like terms here, is equal to, using the distributive property, be really careful about that. And so I should be doing 2 times J and 2 times the 4 to get this right. It's going to give me 2J minus 8. Alrighty, now it's time to do a little algebra. Let's see here. Kind of planning ahead. I think I'm going to go ahead and add 8 to both sides. No matter how you get there, as long as you get there. Okay, so we've got J plus 7 is equal to 2J. Yep, and I'm going to go ahead and subtract 1J in both sides right now. That's J. And kind of running out of room here. 7 is going to equal 2J minus 1J is J. What that's telling me is not the answer to the question. The question is how old is Marcel? But it is giving me Jacob's age, which is very helpful. So first thing I'm going to do is I'm going to put it over here in these columns and just see if it makes sense. So if Jacob is 7, then if J is 7, then if Jacob is 7. Let me use a different color for that one. Alright, 7. So if he was 7, that would make Marcel 10, because he's 3 years older. And Sam is twice as old as Marcel, so he would be 20. So let's see if that's making sense. 4 years ago, all I have to do is subtract 4 from each of these numbers. I would have Sam at 16, and Marcel would be 10 minus 4, or 6. And Jacob would be 7 minus 4, or 3. Now, reading the problem, does this all make sense? Sam is twice as old as Marcel. Yeah, he's 20, Marcel's 10. Perfect. Marcel was 3 years older than Jacob. 10 and 7. Yep. 4 years ago, Marcel was twice Jacob's age. 4 years ago, Marcel was 6 and Jacob was 3. I think we have a winner. We have the correct answer. We're going to move on to another problem now. Feel free to pause if you'd like to look at that a little longer. Okay. The very next problem is probably a little bit simpler, actually. It says Jeff is 2 years younger than Carrie. 12 years ago, Carrie was twice as old as Jeff. How old is Jeff now? So we're going to go ahead and set this up with Carrie and Jeff. And looks like we're going to really need 3 rows. We have 2 people and 2 columns. And we're going to go ahead and just write some names in here. We got Jeff. And we have Carrie. Okay, and time frames that we're talking about. Well, we're talking about 12 years ago, and we're talking about now. Okay, because when they say is, that's present tense, and that means now. So, alright, we're going to go ahead and put headers up here. One will say now, and one will say 12 years ago. Alrighty, and reading the problem, Jeff is 2 years younger than Carrie. So, once again, I'm going to have my variable be a J. Oops, that's going to go right here. Jeff is a little younger. I'll put a little Y here to remind me of that. And Carrie is, well, Jeff's 2 years younger, so Carrie is 2 years older. And this is why I like to put the variable for the younger person, because then I have to add. And that always makes it easier. Adding is always a better thing to do. Okay, now, 12 years ago, Jeff would have been 12 years younger, so the way I represent that is J minus 12. Carrie would also have been 12 years younger. That's J plus 2, her current age, minus 12. Okay? Now, there's a couple other things I know. Carrie was twice as old as Jeff. This doesn't really indicate that, but I do know that Carrie's age 12 years ago was this, and Jeff's age 12 years ago was this. I'm sorry, I said that backwards. Carrie was this, and Jeff was this. Carrie is the older one. You've got to be really careful when they indicate that someone's twice as old or older by a multiple, because when you set up the equation, you're going to have to put a coefficient or a number in front of one of these expressions, and you have to make sure it's the right one. And that's a real common error that people put that, just kind of the way it reads in the problem. Well, since Carrie's older, you're going to have to double Jeff's age, not Carrie's age, because that wouldn't make any sense. So when I write this equation, I'm going to do it this way. 2 times J minus 12, that way I'm going to double Jeff's age, is going to be equal to Carrie's age, 12 years ago. I can simplify Carrie's age by combining my 2 and my negative 12. And I'm going to make that J minus 10. Alright, so using the distributed property here, I'll use a different color. I've got 2 times J and 2 times negative 12. So that's going to give me a 2J minus 24 is equal to J minus 10. Looks like I'm going to need a little more room. So I'm going to go ahead and start over. And when I restart, I would like to just rewrite the last line of the prior column. So 2J minus 24 equals J minus 10. And I will go ahead and, oh, I have a little problem here. There we go. It's not equals 10, it's minus 10. Okay. Now this should have been pink, but that's okay. So what I want to do is, want to end up with only one variable. So I'm going to go ahead and subtract J from both sides. Whatever you do to one side, you have to do to the other. And that's going to mean 2J minus 1J is going to leave me 1J on the left minus 24 equals, these were canceled out. So we have J minus J, that equals 0. But I do need to bring down the minus 10. Then I can go ahead and add 24 to both sides. And what we got here, I'm going to bring down my J. And of course these also are equal to 0. And I've got negative 10 and a positive 24. Looks like Jeff is negative 10 plus 24 is 14. Looks like Jeff is 14. The question is, how old is Jeff now? So if this is correct, we have the answer. But before I do that, I'm going to test it. Okay? I think this is the answer. So I'm going to write these numbers over here and see if they make sense. Jeff is 14 now. That would make Carrie 16. Okay? So 12 years ago, Jeff would have been 14 minus 12, which is 2. And Carrie would have been 16 minus 12, which is 4. Okay? Kind of hard to read that. So reading the problem again to see if it still makes sense. Jeff is 2 years younger than Carrie. Well, that fits. Because 16 minus 2 is 14. 12 years ago, Carrie was twice as old as Jeff. Okay. So if we compare these two numbers right here, Carrie was twice as old as Jeff. Carrie was 4 and Jeff was 2. So we do have a correct answer. Jeff is 14 years old. Right there. And that is the end of the presentation today.